Morning, afternoon even, gas stoichiometry. Okay, so far we've done, I hate that part, so I normally just launch it. Gravimetric stoichiometry. What came after gravimetric stoichiometry? Solution stoichiometry, a special branch off solution stoichiometry were titrations. And then today we are going to cover gas stoichiometry. Okay, gravimetric. What is, like, it's not really a nice word for us, gravimetric stoichiometry, but in science it means something. What does it mean? Gravity, which means your mass versus your weight, right? So it's all about a mass. So in gravimetric stoichiometry, you were always given a mass, which is measured in how many, what kind of units? Grams. And so what formula do we use for that? If you're a formula user, number of moles is equal to mass over molar mass. Where mass is in grams and molar mass is in grams per mole and N is in moles. Right? And this was supposed to be, what are you supposed to only have masses of? Things you can put on the weight scale. And those things are only solids or pure liquids. P-U-R-E-L-I-Q-U-I-D-S. Yes? You don't think this summary is important? You don't think you should be squeezing it on a sheet of paper somewhere? I'm moving on. Come on, you guys are in grade 11. I shouldn't have to tell you to pick up your pens. Good. Solutions. Solutions. What is solutions about? It's about a concentration and a volume, right? And I know you guys are all writing now. Come on, catch up. So, are solutions about solids? No. Are solutions about pure liquids? No, it's not a pure liquid. Zoom, zoom, zoom in. I see lots of different stuff. Right? Not a pure liquid. It's a, well, it's a solution. Right? Heterogeneous mixture, homogeneous mixture, solution. Homogeneous are solutions, by the way. So, but it has to do with the concentration as in how many circles there are in a liter, right? So moles per liter. And how many, what volume do you have in milliliters or liters perhaps? And then we're going to figure out if you're a formula user, you're going to use that formula for solutions. Everybody okay with that? In the titration section, what was tricky about the titrations or new about the titrations? Give me some stuff. Nothing? You knew it all. One thing you learned when we did titrations.
Average volume.
Average volume. Good. So you had to take an average volume of the burette. Oh, burette. Was that not new? Yes? What was new then? Burette and pipette. And what was actually happening with the color change, which we just talked about. The fact that your end point, or equivalence point, EQU, that your equivalence point was your mole ratio. And how reacting those little circles with one drop, I still have an excess of acid, so my thing is still colorless. Add a bit more, react those circles, still have an excess of acid, so it's colorless. Eventually, all my little circles of acid have all been reacted, and I just have neutral products. So one drop of the base, whole thing turns pink. Right? That's that discussion right there. What else? Anything else that we learned? I think this is hard. Taking your average titration, looking for outliers. Right, the anomalies that aren't really important, that we overshot. And, right, if it's overshot, too much has been added and we don't include that in our average. And then this setup is often quite tricky. Would you agree with that? What is my reaction? Where is my known volume, my known concentration? This volume I have to take an average for. That part's kind of hard, I think. So the setup in this needs a bit of concentration. Like how can I do this on my own? Up until now, I've copied the person beside me in my setups. How did they get it? How did you know that that goes there? It's a really important question to be asking the person beside you. Everyone okay? So but other than that, like, so all this sort of little tiny bits are new, but in essence, it's still just solution stoichiometry of two solutions that are reacting together. Okay, so I've done solid, pure liquid, impure liquid, solid, liquid, gas. So for gases, and I'm just going to erase this so I've got a bit of space here. For gases, what did we use for formula in our gas units? What were our gas formulas? Can you remember? Can you pull them out? Come on, brush your teeth. You're reading it. It's over there on a post-it note.
PV equals nRT.
Good. PV equals nRT. And what other formula did I use with the number of moles? Not small m over big M, not mass, volume. So number of moles equals volume over molar volume. Okay, what was molar volume at SATP? And what was molar volume at STP? Right, which one goes with which? 24.8, the bigger number, goes with the more letters, right? That's how we memorized it. 2, 4, 8. 2 times 4 is 8. And 22.4, 2 times 2 is 4. And the smaller number goes with the smaller STP. And then we had P1V1 equals P2V2 and all of those, but those didn't directly have anything to do with number of moles. And of course my whole point about stoichiometry is getting to that bridge where I can convert my units from one to the other, and the only thing that can go on the bridge are my moles. So I don't want to talk about P1V1 equals P2V2 because it doesn't help me get to my moles to get across the bridge. Okay? So although those formulas exist for gases, they're not going to be part of our stoichiometry conversation because it doesn't help. But these two are. And remembering, this is PV equals nRT. These two things are. The only difference is that I've used the pressure at STP, the R constant to more decimal places, the temperature at STP, plug them all in, and I get this number. Okay, so if I use PRT, and I rearrange this to be N equals little v over big V, where that's my little v, for volume, I will get 22.8, 22.4, and 24.8. Okay, so they're not different formulas. It's just that this one's a little bit easier to use and more precise. So, if I have a gas before on a sheet, you might have incorrectly been asked to calculate the mass of that gas. But realistically, I don't want to know how much the helium weighs. I'm more likely to know what volume that helium is going to occupy in that balloon. Not really how much the balloon weighs. Okay, so same thing. We go down the column, cross the bridge on the mole ratio, and another formula I can use about gases then is my number of moles is equal to my volume divided by, for example, 22.4 if I'm talking about STP. Does that make sense? So you've got one sheet to practice this, because I don't think you need much time to practice this. And then on the back, and then that's the end of stoichiometry. Yay! So on the back of that sheet, I've mixed it all up. So you have to decide, what am I using? Which formula am I using? It could be any of these things that I might come across that I will have to access. So then you are making the educated choice on what formula to use. Happy, everybody?
Yep.
Okay.